Hi, in this video I want to show you how to work with string arrays and modify the string array and create a structure from the string array. So let's start with loading our generation.mat file into the workspace. So from the current folder, I'm going to select the file, right click, and select load. And you even see a hint here, right? Here's the load function call method with the character generation.mat. And we see in our workspace, we have the variable data export, and it is a string. If I double click on the data export variable, the variable window opens up, and we see our string array, 170 by 10. And so this is hourly electric generation by source from April 8th from 12 a.m. when it's the last one, for April 15th at 12 a.m. The string arrays can be very useful at times. However, I would like to create a structure from this string array. And I plan to use the column headers as the field names of the structure. There's a problem though. If I type in help, struct, struct, get a text version of the help page. So the struct command, the struct function rather, allows you to create a structure. Within parentheses, we have the field name, and then the values separated by a comma. If you have a second field name, separated by a comma, and so on, dot, 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 right? Now notice here that they are using field names as characters with single quotes. I want to highlight that fact because, remember, the MATLAB functions across the platform use interchangeably strings or characters. So if you use the struct function, you can use strings or characters. Now, as an example, at the bottom of the page, they're showing struct and characters for the first field named type, and there's a cell array, and then the second field name is color with the value red as a character. Third field name is X, and the values as a cell array 3 and 4. So let's try that. I have struct, so I'm going to have a field, and I'll use the character single quote. Now I'm going to create my first field name is called field name, and notice by design I'm putting 2 words with a space, comma, and let's just make this a vector 1, 2, 3, and see what happens. So we have the field name, character, comma, values. And it says invalid field name, field name. So I'm going to take a guess here and say the why it's invalid is the space. If I try it without the space, correct. Okay, so the lesson here is the field name cannot have spaces in it. It has to be continuous character or string. So how about if I want to be a little bit more descriptive and I say I have a field name, I'm not going to create a space, so I have parentheses and the word data and close parentheses, and it's in my single quotes, comma and value. I get another error, invalid field name. So parentheses are not acceptable in field name. How about underscore? Underscore works. Spaces, parentheses. How about asterisk? So you see the pattern here is it's the same rules as the valid variable names. No spaces, no special characters, and the exception for characters is underscore. That's acceptable. So why did I go through that is if we go back and take a look at the data export string, well, in the column headers, we have spaces for region code, we have spaces and parentheses, and our timestamp, and now we have spaces and parentheses in around milliwatt hours. So this is a very good opportunity to do some string manipulation programmatically to modify those elements of the string array so I could use them. I'm going to take a look at the erase function. So erase function, and I'm using the help command again to highlight the fact when you write your functions, the comments in your custom function are very important to help the user to learn and understand how to use your function. So the high-level description says erase, remove content from text. Well, that's what it does, right? So now we see a syntax version here. So erase, so we have str. There's a function called str and match. And it removes the occurrences of match from the string. So I have a string as the input argument to the erase function, and match is the item or the character that we want to erase. So if I go back to our data export variable, data export, if I access first row, first column, I get a string of region code. So this is what I want to erase the space from, right? So data export, 1, 1 is my string, and I want to have a comma. What is my match? My match is the space. I want to erase the space. So let's see if this will work. So I'm using double quotes from my double quotes, space, double quotes. So my character is actually a space. And that works successfully, right? ANS is now assigned a variable of region code without our space. So before we erased it, we had the space. Now there's no space. What about our second header, column header, which is timestamps? So now look, it's a little bit more complex, but remember in the help page it said occurrences, plural. So let's look at our timestamp. That is row 1, comma 2 for column 2. And so we have a string. It has spaces and parentheses. So trying our erase again. Data export 1, comma 2 is our string. What is our match? Well, let's find the spaces. Let's see what happens. Okay, so now notice the occurrences, we've eliminated or erased the 2 spaces between timestamp and the parenthesis, open parentheses, and in between hour and ending. So next, we can attempt to eliminate erase rather our open parentheses. So that's my match. Now what is my string? Well, how about if I just use my previous expression to erase the spaces? So now we have our string will be the cell data export 1, 2. We're going to erase the spaces. And then the next erase function call will erase the open parenthesis. Success. So I'm going to do the same thing. I want to match the closing parenthesis and use the previous expression as the string. Pasting it in there. So we completely erased all the spaces and both opening and close parentheses using the erase function. with expressions for our string. So now, just thinking ahead, I could use that string as my field in my structure. So let's try that. If I create a structure name from struct, the struct function, and the first term in the struct function was the field name as a string without spaces or special characters, so we're valid there. And now the value for that field name is going to be what? This would be, we're working with the timestamps, so data export, so we're indexing what data export we want. Column 2, which is the first timestamp at 12 a.m. I'm sorry, row 2, correction, row 2 of column 2. So we have row 2, and we want all of the values, so I'm going to use the keyword end. So I want row 2 all the way down to the end of the string, which is 170 rows long. And the column will be column number 2, right? So all the rows for column number 2. Checking my parentheses are matched up. And success. We created a structure. Structure name data. With the first field, timestamps hour ending, and it has a string for values. So let's take a look at that. Data, field name, timestamps, and the values for the timestamps are all the strings from the data export string array. So I could use that same format to include the first 2 columns and to add it into my structure for the 2 fields. So for example, data 3 I create as a new structure name is equal to the struct function. So I'm going to erase the spaces from data export 1 and 1 comma 1, which is the region header, and add the data for the first column, and then for the second column, erasing the spaces and parentheses, and the values for the timestamp is column 2, right? So now that's all fine, right? But I'm kind of feeling a little bit lazy here. I have to do that 8 more times. I have 10 columns. How about if I just go through a for loop and let MATLAB do the work for me? So I accomplished the first 2 columns. So I could do a for loop for I is equal to 3. In this case, my data export is 10 columns long. But gee, I don't know, what if I download some information sometimes in the future and it may have more or less columns? Let's kind of be efficient here and say I want to use size of data export, number of columns, so I use 2. Now in the future, if the columns are less than 10 or more than 10, it doesn't matter because we're going to go through 3 to the number of columns in data export. And what am I going to do? I'm going to again erase spaces and parentheses. Open spaces here, open parentheses, close parentheses. And that's going to be my field name. Because my I increment value is here for data export for the column number. So my field name is going to be the first row. Column number 3 will be the first increment. And then what is the value going to be assigned to it is a conversion from double from the data export type from row 2 to end column number 3 for I. So remember, what do we call this? This is creating dynamic field names with the variable. So by using the for loop, I'm using dynamic field names for the variable, and let's see what happens. End, and we have success. So let's look at our data 3 structure. Now we have a complete structure. Data 3 is the name. How many fields do we have? We have the region code, the timestamp, hour ending, wind generation megawatt hours, solar generation, hydro generation, other, and so on. So all the field names are valid. There's no spaces, no special characters, and the region code and timestamp hour are class string, and the generation data for megawatt hours are numerical doubles. Why did I continue to use the string? Because in this case, a string was a good choice in my mind because we have numbers, we have special characters with the slash, we have space, we have A, M, and periods, and EDT with spaces. So a string type makes sense for that. Numerical double types make sense for the wind generation or whatever sources of generation it was, right? So it's a pretty quick example using strings, string manipulation, and the erase function. We want to manipulate the strings to make them more useful for us. So what did we do? We had to get rid of the spaces and special characters because I wanted to use the strings as field names programmatically using the for loop. So in my mind, it was very efficient. I didn't have to, I saved a lot of typing to generate all these names. My input data files available for me. It had text across every header. Manipulated the strings, put it in a for loop, created a structure with the fields. Now we have a data structure that we could save. I'll use the save, and this is the command version, not the function version, because we're not using parentheses, file name, and what I want to save. Data 3 is my data structure. If I clear my workspace, now I can go to my current folder, simply right click, load, generation data, and it's all back. So now I could write a program, load my data into the file, into the program, and do some calculations or analysis. We'll save that for a future video. Thank you for watching.